I'd like to discuss what a vapor pressure is. Here, there are three different flasks here, and all of these three flasks are corked on top. Now, these flasks have three different liquids here: water, HCl, and Cl2. For water, this is experiencing only hydrogen bonding. So this is the intermolecular forces is hydrogen bonding here. For this liquid, it's experiencing just dipole-dipole. And this one is experiencing London dispersion forces only. Now, of course, there is London dispersion forces here as well. It's not only limited to the hydrogen bonding and dipole-dipole, but it is dominated by hydrogen bonding for this one and dipole. Now, these are all in liquid phase. So the bottom here is in liquid. Some of this liquid could go into a vapor phase or gas. Okay, even if there is no heat added, just by room temperature alone is enough for these liquid to form into gas, just in randomly. So for example, this water, you can see how some of the water molecule forms into a gas, breaking the hydrogen bonding so it could freely float around. Same for chlorine, it can break the dipole-dipole within the liquid molecule, and then now the gas is sort of floating around. Same for London dispersion forces. Note the amount of water molecule going into a vapor phase, HCl going to the vapor phase, and then Cl2 going into vapor phase. The one in the water, it doesn't go into vapor phase as much. For this one, it's going to go into vapor phase a little more and a lot more here. And that's because it's really hard to break the bonds here in comparison to this one and in comparison to the last one. So because if all of these three flasks are all at room temperature and they're as is, you're not going to see too much of water molecules being broken apart compared to the other two. And probably even this one will all just be vapor. So therefore, what is vapor pressure then? It is the amount of these vapors that are on top of the liquid exerts a pressure onto the flask here. So if it has a lot more molecule, don't you think it would have a very high vapor pressure? Yeah, so this one will have a very high vapor pressure, this one a little less, and this would be the lowest because not enough vapors are hitting against the wall of the container. So hence the pressure is low. So how does this relate to intermolecular forces? It relates to intermolecular forces in that you can see in vapor pressure, something with just hydrogen bonding will have a very low vapor pressure because it requires a lot more heat in order for it to break. So not much will go into vapor. For second ones for dipole-dipole, that will have the intermediate vapor pressure. And the last one, something with just London dispersion forces will experience a very high vapor pressure because if the liquid form vaporizes very quickly, even with a very small amount of heat, exerting pressure onto the container that it holds. Let's do a learning check. Which of the following has the greatest vapor pressure? Ethane, ethanol, and dimethyl ether. Just to give you a quick hint, all hydrocarbons are considered to be non-polar substance. So with that hint, try this and come back and check this video. So coming back, ethane is a hydrocarbon, meaning that it is a non-polar substance. All non-polar substance will only participate in London dispersion forces. So this is LDF. Ethanol, it looks like a hydrocarbon since it has carbon and hydrogen, but that is not the only thing. It's got an oxygen and a hydrogen. So that oxygen being directly attached to hydrogen, this can participate in hydrogen bonding. Not only that, they can also participate in London dispersion forces as all either non-polar and polar substance can participate in London dispersion forces. This one is only LDF. That's because it's a hydrocarbon. It's a fully nonpolar substance. Dimethyl ether, this one will participate in dipole-dipole. You might wonder why not hydrogen bonding since there is an oxygen, but that oxygen isn't directly attached to the carbon. Comparing to the ethanol, it's directly attached to oxygen to the hydrogen. However, this oxygen is not directly attached to the hydrogen, hence why it is not hydrogen bonding. The second option would be dipole-dipole and finally London dispersion forces. So that still doesn't identify which one has the greatest vapor pressure. Remember, the one that has the weakest intermolecular force will have the greatest vapor pressure. So therefore, ethane has the greatest vapor pressure. I will go ahead and box that. The second greatest would be dimethyl ether, and the lowest vapor pressure would be ethanol.